Standard Industrial. We created a series of tutorials to make sure that you have the information needed to get the most out of your Standard Industrial equipment. When you're done with these lessons, check out the other skill building videos on our YouTube channel, and thank you for choosing to make Standard Industrial part of your business. In this lesson, we'll learn how to enter a VDI into the tooling database. First, click on the tooling database icon. Ensure that you're in the correct program list. In this case, we are in the die list. Move to the bottom of the screen and select New Drawing. It's important before you begin to enter the die that you have a drawing that has all the critical dimensions. In this example, we're using a tapered die, which is thicker at the bottom than it is at the top. Because the back gauge operates at or slightly below the top of the die, it's the width at the top of the die that we need to record. We'll begin with the width dimension. In this die, our width is 3.25 inches. The height of the die should include not only the height of the die, but also the height of the die holder. So the height is truly the total height from the bed of the press brake to the top of the die. It would include the die itself, the die holder, or anything in between the two that add to the elevation of the die. Ultimately, this is the measurement from the top of the die to the bed of the machine. In our example here, the actual die I'm working with is 3.25 inches square. However, it sits in a die holder, so our height of our die is actually going to be 5.25 inches. The height is a very critical dimension of the die. If the height is not expressed properly, it can create tooling collision issues, so make sure that the height you record is accurate. We'll see in our drawing that we now have the tickered lines that indicate the crude dimensions of the die, and the drawing starts out with a horizontal line on the left-hand side. Drawing dies will always happen in a clockwise fashion, so as we draw this die, you'll see that the drawing progresses from the upper left-hand corner in a clockwise manner. And you'll always start here in the upper left-hand corner drawing the first shoulder of the die. The first dimension that we'll enter is the length of the actual shoulder. So here we'll enter 1.25 inches. And this is where the V begins to enter the die. Now, there's a feature that makes it easy for us to enter a V, which is the button down here, Insert V Die. So we'll insert the V, and we'll be asked some questions now about the dimensions to shape the V properly. The first question is the alpha, which is always a angular dimension, and what it's asking is what is the angle of the V die we're using. Here we're using an 85-degree air bending die. Next, always the L indicates the length, and if we look at the graphic that's aiding us here, we can see the L is drawn between the left shoulder and the right shoulder, so it's asking us what the length of the actual V is. In this case, this is a 3/4 inch V opening, so it's 0.75. Next, when we see the R, it's asking for the radius. Now, on a V die, the radius, or an air bending die in particular, the radius that it's asking for is the shoulder radius. Some tooling drawings will also include the bottom radius, but because this is an air bending die and we won't be touching the bottom of the die, here it's asking for the shoulder radius. So the shoulder radius on this particular die is 0.156. Next, it's asking for the load factor. Here we want to make sure that we have information that's been provided accurately from our tooling provider. The CNC control uses this loading information to prevent overloading of the tooling, so Having this information accurate is important to making sure that your operators maintain safety. In this case, the load for this die is 22 tons per foot. Please take note that die load information is entered in tons per foot. Now you'll notice that after I entered the tons per foot information, it appeared that the data disappeared. What's happening is the data entry fields constantly scroll upwards, so as we move to the next field, the previous data may scroll off the screen, which is what happened in this case. If for some reason we needed to move back and to review or to change the information we previously entered, you just select the arrow backwards and it will scroll the information back down into your view. You'll also notice that the highlighted area on the drawing corresponds to whatever section you happen to be on. So we've moved backwards back to the V information, so the V is turned red and the information for the V die is visible in the field. We want to move forward to the new tangent that we're drawing. Now it's highlighted and we're at the input fields to affect that information. So here it's asking us for the length of that shoulder, and it's going to be 1.25 inches. So now we've drawn the top shape of the die. We have both shoulder lengths and we have all the information necessary about the V, and we're being prompted with the alpha, which is always asking us for a degree, and in this case that degree is a direction. It's wanting to know what direction the next line is, which would be the sidewall of the die. And so here we're just going to push straight down, and it's going to ask us, well, how long does that need to be? Well, we know that the total height of our die is 5.25 inches, so here the height will be 5.25 inches. Next, we're asked for the next alpha, which direction is the next line heading, and so we're going to push to the left, and as usual the L is asking us now how long will this line be. We know the width of the die is 3.25 inches, so we'll enter 3.25. Now we're at the point to drawing the last line in the drawing, and to do that the feature closed drawing is always used. The closed drawing feature is used to draw the last line segment so that the mathematical rounding that's necessary to meet the CNC requirements is entered. You would not be able to calculate down to the decimal level what the true length of that line is, and so the CNC control does it for you with the closed drawing function. So here we'll click close drawing, and that will complete our V die. So now we have all the correct information about our V die, and we'll need to save it in the die list. We do that by clicking on the computer icon and selecting an alphanumeric name that's up to 30 characters long. So in this case, this can be stair die. Hit OK, and your die is saved. To validate that it was saved correctly, we can go back up to the tooling database icon. Now you'll notice that we are on the punch list, so we'll have to toggle that again to get to the die list. And here we see a misspelled stair die. So that mistake is a great opportunity to show you how to actually correct a die naming error, because it will probably happen to you at some point. Here we go down to the menu area and we simply select rename, making sure that the die that you want to rename, of course, is highlighted. So we click rename, and we have a second opportunity to do this correctly. Yeah, it looks a little better. Click OK, and now you see that stair die is corrected. So our die is in our database now, and it's ready for us to use in production mode. I hope this tutorial has been beneficial, and if it has, we need to ask a favor of you. In order to keep this site visible and to continue to bring this material to you for free, we need you to become a subscriber. We promise if you do that we will not send annoying solicitations to you. The only time you'll receive notifications is when we post new material to the site. So please subscribe, and thank you again for choosing to make Standard Industrial a part of your business.